Alright everyone, today we're going to kind of review for our test tomorrow on the review of all polynomials, of the adding, subtracting, and all the interesting things that we have learned with basic ideas of polynomials. So let's get started. Alright, so the first thing this video is going to cover, this is all the fun things we're going to see, okay? Oh, what's the matter, Gwen? Is we're going to classify polynomials by monomial, binomial, trinomial, polynomial, or neither.
Let's say
okay.
you wrote 5.
We're going to talk about degree.
Okay.
We're going to talk about adding and subtracting the polynomials, multiplying polynomials, special products, function operation, and area and perimeter.
6 by 5, and how much is that?
Okay, so we're going to talk about all that fun stuff. No, that's my pen.
So we multiplied, right?
Okay. All right, so let's talk about
The
monomial.
product was...
Okay, so Gwen,
What is
here,
the
you want to
product?
see you? See you? Here we go.
By 6?
Alright, so there's the Gwing Gwing. See, look at Gwing Gwing.
Chocolate milk.
Yeah? You want your chocolate milk? Alright, there's your chocolate milk. Okay? Alright, so I'm going to scooch this over here so I have room to work. And Gwen can see herself actually. I'll scooch over here so she's over here. Yeah. Alright, so let's start off with a monomial. Remember, a monomial... Oh, that's nice. A monomial is basically a one-termed piece with no plus or minuses. No pen, that's mine. Here, here's a pen for you. There you go. So again...
Push a button.
Well, yeah, it's right there. Okay, so we're going to start. So monomial is a one-termed piece, okay? So things like 3x would be a monomial. Yeah, it's got multiply in there, but again, it really doesn't matter all that. That's nice. Because there's no plus or minuses. The plus or minus is what splits. Yes, my hair, what's left of it. Thank you. So now, then we have x, another classic monomial. We have things like 3x over 4. Okay, so hold on. Oh, Gwen, hold on. Let's fix this. Yeah, I see you too. Okay, let's fix this. We'll delete that and make a new one. Yeah, we'll fix it. Yeah.
2/4 of the playground is covered.
Okay, there we go. So stuff like that. Gwen, the picture's back. Here she comes. All right, so again, that would be your ideal monomial right there. See, there she is. Yep, you're right there. Okay. Now, a binomial is what bi meaning 2. So we're going to have 2 pieces. So, yeah, so stuff like 3x plus 2. Because now I have the plus in here separating it into 2 separate pieces. Okay. We're going to have x minus 4.
Right?
Okay, again, because of the minus, it separates it now from one piece to 2. And even with the fractions, let's say 3x over 4
So 2/4, color in 2/4.
plus, let's say 1/2. Okay, so that would be a binomial, 2 pieces. Yeah.
So
Trinomial is going to have, obviously, 3 pieces. So let's do 3x squared plus 3x plus 2. So we have that
whole
one.
number or a fraction.
We'll have something like x squared minus 4x minus 4. That's a trinomial. We have, let's say, 1/3 x squared minus 2/3 of x plus 1/2. Okay, where we have now 3 pieces because of the fact it was separated by a plus or minus. So those are our basic classifications. So let's move on to the next slide. Alright, so here we go. Now, we have to discuss about when things are not a polynomial. So there's basically 3 rules we have to watch for. Okay, so the 3 things we have to watch for is an object is not a polynomial when there are negative exponents on the variables or variables in the denominator of the fraction. So for instance, negative exponent on the variable. So say we had x to the -4th. Okay. Now the reason why I can have this, because remember, this is equivalent. We've talked about negative exponents, that when you have a negative exponent, it indicates that the piece is in the wrong place at the wrong time doing something stupid. So we have to move it to the denominator. So what this really says is 1 over x to the 4th. Okay. Now, we can't have this because of the fact that, remember, a variable can be any value we want it to be. So if I say, okay, I want to make x equal to 0, say we say x is equal to 0, therefore, we are going to now have the fraction 1 over 0 to the 4th, which is 1 over 0, which we know doesn't exist. Okay, so we can't have something like that occur. So that's rule number 1. Error number 2, no variable exponents. So we cannot have something like 3 to the x. Okay, can't have something like that because of the fact that it also would create issues in terms of graphing something like that. So we can't have something like that as a polynomial. And no fractional exponents. So something like we have x to the 3/4 power. Because if I have something like this, and again, when you learn in Algebra 2, what this really means is we are going to be dealing with the 4th root of x cubed, which we cannot have. Okay, so we have to be careful for something like that.
Is this the same one?
Yeah.
All right, so the next thing we're going to talk about is finding the degree of the polynomial. Now, very important that you're going to see is it's the sum of the exponents of the variables. So if there's an exponent on the regular numbers, that doesn't count as part of your summation or your degree here. Okay, so let's take a look at something like this. Okay, now we're going to start with a simple monomial. So in this case, the degree or the exponent that I have showing here is a 4. So you would say the degree of this monomial in this first example is going to be just 4. Now another monomial that I have here, I have 2 variables. So again, I'm going to add these exponents together, and now I'm going to have a degree of 11. Now the fun part becomes when it does something like this, where you have a trinomial or something bigger. Now what you're going to do is we're going to split this up into its monomial pieces, okay, and we're going to do the degree of each part. The largest sum is going to be the degree of the trinomial. So for instance, right here, this is going to be 11. I add these pieces up here, so 5 and 5 is 10, with 6 is 16. Here, now you got to be careful, there is a 1 hiding here, so add those up, I get 10. So, to identify the degree of this huge trinomial here, we find the largest piece, which in this case is going to be the 16. So the degree of the trinomial is 16. Okay? Let's continue our review. Okay, adding or subtracting polynomials. Pretty simple stuff. Okay, so to add, again, it's an addition because we have a plus between our parentheses. So we're looking to combine like terms. Okay. Okay, let's try this again. So again, we're looking for like terms. Okay, so we're going to start with our x squareds. Okay, so we're going to take our 2x squared, and we're going to add negative 4x squared, which is just basically subtracting. So 2 minus 4 is negative 2x squared. And again, remember, we do not touch the exponents here. Okay, now we go to the regular x's. Negative 3x plus negative 8x. So negative 3x minus 8x is negative 11x. And then we have the constants. So 5 plus 7 is going to be 12. And there's your sum. Okay, pretty easy. Okay. Now, when we do subtraction, we have to be a little bit more careful. We're going to take the negative, and again, we're going to change that over to plus. And in doing so, we change all the signs and the pieces directly behind the minus sign here. So this goes to a now plus 4. This goes to a plus 8, and this now becomes a negative 7. Okay, so now that we did that, now we're back to what we were just doing, adding and subtracting. So let's go. 2x squared plus 4x squared is 6x squared. Okay, the x is negative 3x plus 8x. That's going to be 5x. And then we have positive 5 minus 7, which is negative 2. And there's that. So again, adding and subtracting, very basic. Just watch out with subtraction. You got to watch that minus. We got to change that to plus. And then it's pretty simple to do after that. All right, so let's keep moving on. All right, our next one, multiplying basic polynomial. Now again, you may hear this called many different things. Foiling, double distribution, Tor attack method, okay, stuff like that. So again, what we're basically going to do, I'm going to demonstrate two ways you can do this. And again, you can select whichever way you like the best. Okay, the first way is to kind of be doing the traditional FOIL method, okay, that says we're going to multiply first piece to first piece. So x times x is not 2x. Remember, x times x is x squared. Okay, then we're going to do x times 5. Well, that's 5x. Okay, now we do the underneath. Negative 3 times x is negative 3x. And then we have the negative 3 times positive 5, which is negative 15. Okay, now that we have this, now we're combining our like terms. So we look, are there any other x squareds in this problem? No, so it's x squared. Then we look to combine our x's. So usually they're going to be in the middle, but not always, so just be careful of that. So 5x minus 3x is plus 2x. Then tack on this lonely little minus 15, and there's your answer. Okay, so that's kind of the traditional way to do this. Now, the other way that I've seen over the past couple of years, students kind of like it, but yes, it is a little bit more work, is using the box method. Okay, so what we're going to do is we're going to take our first parenthesis, so we have 2x plus 5, and we put that on the top. Okay. Then going downwards, we're going to put the second parenthesis, we're going to have 3x minus 2. Okay. Now what this does is it creates for us pockets of multiplication that we're just going to do out. So for this first one, we're going to do 2x times 3x. Well, 3 times 2 is 6. X times x is x squared. Okay. Then we're going to do our multiply. So we're going to do 5 times 3x. Well, 3 times 5 is 15. So positive 15. I usually use a plus. You don't have to. Then x with nothing there is just x. Okay. Now we do our next part. So we're going to do this 2x here times the negative 2. So negative 2 times a positive 2 is negative 4. Come on, 4. There you go. Oh, come on. Come on. There we go. And then the x with nothing there is just x. There we go. And then we have the positive 5 times the negative 2, which is negative 10. So that means at this point, now it's kind of organized our data for us a little bit. Now, in most cases, when you do the box method, you're going to find that like terms are commonly on diagonals with each other, but not always, so don't fall for that trap. So at this point, we're combining like terms just like we did over here, okay? So we're going to start x squareds. Do I have any other x squareds? The answer is no. So 6x squared. Now my x's, again, look on the diagonal. They're right here. So we can do 15x minus 4x, which is 11x. And then tack on the minus 10. So something like that. Now again, the question my students commonly have is, well, gee, which way should I use? That's totally up to you. Again, it all depends on how you see things. If you are looking at this first way and going, yeah, I can't really follow that. I make a huge mess. I can't do stuff like that. I can't really follow that. then I would suggest using the box method to organize yourself. Some students will say, well, I like the first way better, it's less work. And that's fine, less work's okay, but if you're not getting the right answer all the time, I would suggest using the box method to help you out. All right, so let's move on. All right, so let's take more multiplication. Okay, so some bigger pieces. Now, like I said, you can use the traditional FOIL method or however you like it. I'm going to demonstrate more the box method on these types of problems to keep things kind of well organized for us. Now again, if you like the kind of the loop method or rainbow method, stuff like that, you're more than welcome to go ahead and use something like that. And again, for our intents and purposes, I'll demonstrate using more of the boxes for those students who need that kind of reinforcement. Okay, so let's start off. So again, I'm going to start with this. So I'm going to have 2x plus 5 here. I'm going to have the x squared minus 3x plus 1, like so. Okay, so what we're going to do now is we're going to do our multiplication. Now be careful though. We're going to take 2x and times it by x squared. Now remember there's a 1 hiding here, so 1 times 2 is 2. X squared with x. So I have 2 x's multiplied together here, and I have 1x multiplied here. So that's going to give us 3 of them. So that's x cubed. Okay. So now we'll do the next piece. We're going to do the 5 times x squared. So that's easy. That's going to be plus 5x squared. X, not an I. There we go. All right. Now I'll go to the next level. So negative 3x times 2x. So negative 3 times 2, that's negative 6. X times x is x squared. Okay. Negative 3x times 5. So negative 3 times 5 is negative 15.
Okay, Bella,
X with nothing there is just x.
Unless you want to work a little bit longer.
And now finishing up, 1 times 2x is plus 2x. And 1 times 5 is 5.
You are, baby.
Okay. So now at this point, let's combine our like pieces. We start. Are there any other x cubes out there? No, there is not. So 2x cubed. Squareds. Okay, negative 6x squared plus 5x squared. That's just negative 1x squared. Now again, if you want to put the 1 here because it makes you feel all warm and fuzzy, you can certainly do that. It's not really necessary. I would not mark it wrong if you did that, just to make sure you're right. Okay. Okay. So, of course, now it's not going to erase it, is it? Okay. So now let's go to the regular x's. So we're going to have 2x minus 15x, negative 13x.
You know, I'll be checking tomorrow.
And then
Make sure
plus
that
5.
it's all been checked off and everything like that.
Yeah.
So there's that one.
Um,
All right, so let's go a little bit larger. We're going to a 3 by 3.
Go get your lunch.
2x squared,
And you guys want to pick out my cake?
5x minus 2,
My cake?
3x squared, minus
I'm gonna throw some
1x.
clothes on, Daddy.
Okay.
You got Gwen?
I'll take care of the Gwingwin. Plus 4. Especially if she's watching the Umizoomi. She'll be okay.
Yeah, she's on the floor.
All right,
Eating her
good. All right, so let's start. 3x squared times 2x squared. 3 times 2 is 6. X squared and x squared. I have 2 x's here, 2 x's here. That makes 4. So it's going to be x to the 4th. Now, 3x squared times 5x. 3 times 5 is going to be 15. X squared and x. I have 2 x's here. I have 1 x here, so that's 3 x's, so x cubed. Now we're going to have 3x squared times negative 2. So 3 times negative 2 is negative 6. X squared with nothing there is just x squared. Okay. All right, so let's go to the next level. Okay. So we're going to have negative x times the 2x squared. So negative 1 times 2 is negative 2. X with x squared. I have 1x here, I have 2x's here, so that makes 3, so x cubed. Negative 1x times 5x. Negative 1 times 5 is negative 5. X with x, I have two x's now, so x squared. Negative x times negative 2, so negative 1 times negative 2 is positive 2. And then we have x with nothing there, which is just x. Okay.
No, Bill. No, Gwen.
Gwen, no.
All right.
Daddy's stuff.
So now let's go to the bottom. 4 times 2x squared, so that's going to be 8x squared. 4 times 5x, that's 20x. And 4 times negative 2 is negative 8. Alright, so now at this point, let's combine like terms. X to the fourths. 6x to the fourth. X cubed, I have right here. So 15 minus 2 is 13x cubed. The squareds, 8 minus 5 minus 6. So 8 minus 5 is 3. 3 minus 6 is negative 3x squared. The x's, 20 plus 2, that's 22x. Minus 8. And there's that one. Okay. Alright, let's move on. Alright, special products. Now again,
I'm sorry, Kish.
so remember with an exponent outside of a parenthesis with a plus or minus in it,
I'm tired of you hitting me.
means we have to write this twice. That's what this means. We're going to write this twice. So in our example problem, x plus 3 being squared means we're going to do x plus 3 times x plus 3. Okay. So now we're going to set up our boxes if you want. So x plus 3x. Actually, before I do that, let's do the example problem so we can get the formula for it. There is a special formula for this. Okay. So let's start. We'll do the a plus b and a plus b. Okay, so here we go. A times a squared. A times b is ab. Most students get that. Now here's the tricky part for some students is, I'm going to do b times a. And they say, well, gee, that's ba. Which is true. But again, in algebra, we like to have the variables in alphabetical order. So if I just flip-flop BA, I get AB. Okay, and then we have B times B, which is B squared. So now remember, there are ones hiding here. So when I combine my like terms, A squared is A squared. 1ab plus 1ab is 2ab, and the b squared is just b squared. So this is our special formula for a plus b being squared is a squared plus 2ab plus b squared. And again, the only difference is if there was a minus in here, there'd be a minus here instead of a plus. That's the only difference. Okay, so let's do our example problem. So we get rid of all that. Okay, so let's do this up. So we're going to do x plus 3, x plus 3. Okay, so let's multiply. X times x, x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. So now if I add this together, okay, x squared is x squared. 3x plus 3x is 6x. And 3 plus 3 is 9. Now some of you are probably going, well, gee, why did we derive that formula from the original problem earlier? Here's, again, just a basic explanation. We take our example again, x plus 3 being squared. If we accept that the x is my a value, and we accept that the positive 3 is my b value, and if I fill those into my formulas, So a squared plus 2ab plus b squared. Okay. So we're going to take x, we take our a and square it, so you get x squared. Okay. Now if I take this value here and times it by 2, I get 6a, or xy. I'm sorry, screwing up here. Hold on here. Let me fix that. Okay, so if I do put the 3 in for my b, because that's what it is. Kind of screwed this up a little bit here. Let me fix that. So if I put the 3 in for b, right, I'm going to have 2 times x, because a is my x, and b is my 3, plus, and then we're going to take our b, which is 3, and square it.
Look what you did with that.
What happens? X squared plus 6x, because I multiplied 2 times x times 3 is 6x, plus 9, which is what we got in the first place. Okay, so there's that explanation. All right, now let's go to the other side. Okay, so we'll put together we'll derive our special formula for this. So if we're doing our a plus b, a minus b, okay, so a times a squared. A times b, ab. A times negative b is negative ab, and negative b times b is negative b squared. So if I were to combine my like terms, I'm going to have a squared. Now, negative ab plus ab completely cancels, leaving just minus b squared. Okay? So there's our formula for that. So we're going to have a squared minus b squared. Okay? So, and we'll go back to that just like we did on the other one. So let's take a look at our example. Okay, so let's do x plus 3, x minus 3. So when we multiply, x times x is x squared. X times 3 is 3x. Negative 3 times x is negative 3x. And negative 3 times 3 is negative 9. So when I combine my like terms, x squared is x squared. Negative 3x plus 3x, again, cancels. Goodbye. And then we have minus 9. Now again, using our formula, if I had the x plus 3, x minus 3, okay, so what they say to do is, again, here's your a, here's your b. It really didn't matter here. So if we're doing a squared minus b squared is our formula, so we put that in for here, so x being squared is x squared. The minus stays where it is, and then we take our 3 and square it. Well, 3 squared is 9. Just like what we got doing it the long way. So again, depending on your teacher, they may expect you to know the formula. Some teachers say, you know what, it's nice to know them, and you could just multiply them all out. So again, just know your teacher, know what they're asking you to do. But here we've demonstrated both ways of doing it. Okay, so let's move on. All right, now we're going to do function operations. So I give you the functions. F of x is equal to 3x minus 9. G of x is equal to 4x plus 3. I ask you first to add them. So function notation, we are told f of x plus g of x. So start by replacing the functions. So you're going to do 3x minus 9. That's my f of x function. Plus my g of x, 4x plus 3. And then do what we were doing earlier. Since it's addition, we don't worry about any sign changes. Let's combine like terms. So 4x plus 3x, that's going to be 7x. Negative 9 plus 3, well, that's negative 6. And there it is. Simple. Now for the next one, we're going to do g of x minus f of x. So start by substituting the equations in. So you're going to have 4x plus 3 minus f of x, which is 3x minus 9. Okay, now as we said earlier in the video, it's a minus here. We don't like that. So let's change that over to plus. And we change all the signs in the parenthesis behind it. So this becomes negative 3x. This becomes a positive 9. And now we're back to just adding and subtracting. So let's do this up. So 4x minus 3x. So minus the 3x. Okay. So when we do something like that, we're going to have just x. Okay. Now we go for the regular numbers. So 3 plus 9, that's going to be plus 12. And there you have it. So there's this one. Okay. Now let's get to the multiplication part. Okay, so we're going to multiply f of x by g of x. So again, our f of x function is the 3x minus 9. So 3x minus 9. Okay. Then we're going to do this by the g of x function, so 4x plus 3. Alright, so let's keep moving here. Let's begin. So again, let's do 4x times 3x. That's 12x squared. 4x times negative 9, negative 36x. 3 times 3x is plus 9x. 3 times negative 9 is negative 27. Alright, so once we have this, let's combine our like terms. So x squared, no other x squared, so 12x squared. Negative 36 plus 9x, that's negative 27x. And then we have this minus 27, tack it on, boom, there it is. And there's your answer. Okay, so just be careful with your operations, what's going on, and also be very cautious of the order in which the functions are coming, because that can create a lot of problems if you're putting them the wrong way. All right, let's move on. All right, area and perimeter of a rectangle. So remember, perimeter, you are adding up the sides and all the sides. So again, this is going to be 4x minus 7 here. This is going to be 3x squared minus 4x plus 2. And that's a horrible minus, by the way. Let me fix that. That looks terrible. Minus. Okay. So again, what we're going to do is add up all the like terms as we go around the object. So let's start with our x squared. So 3x squared plus 3x squared is 6x squared. Okay. X's. So let's do negative 4x plus 4x is 0. 0 minus 4 is negative 4. Negative 4 plus 4 is 0. So there's no x's. Perfect. That worked out nice for us. And then last but not least, let's do the constants, or the regular numbers. Okay. So let's do 2 minus 7. That's negative 5. Negative 5 plus 2 is negative 3. Negative 3 minus 7 is negative 10. Okay, so we have that. Now again, yes, some of you may know to find perimeter of a rectangle, it's 2 times the length plus 2 times the width. Oh, come on, pen. Oh, you shut off again. 2 times the width. So perimeter would equal 2 times your length of 4x minus 7 plus 2 times your width of x squared, 3x squared, sorry, 3x squared minus 4x plus 2. Okay, you would use your distributive property here, so you would have 8x minus 14 plus, now you're going to have 6x squared minus 8x plus 4, and then combine your like terms. So 6x squared, perimeter, oh, I forgot the equals here, 6x squared. 8x minus 8x cancels. And then negative 14 plus 4 is negative 10, as we got above. Okay, so again, it really doesn't matter how you do it, as long as you're getting the correct answer. Okay, now area, Now area, remember, this is important. This is where we're doing length times width. Okay, so this time when I multiply this, the area equals my length, 4x minus 7, x minus 7, with my 3x squared minus 4x plus 2. Okay, now again, you can use the box method here. I'm going to use kind of the traditional way to do this, just to save myself a little bit of time. So 4x squared times 4x times 3x squared is 12x squared. Cubed, sorry, 12x cubed. 4x times negative 4 is negative 16x squared. When I do this, then I have the 4x times 2, which is plus 8x. Okay, now for the second wave, negative 7 times 3x squared, that's negative 21x squared. Negative 7 times negative 4x is plus 28x. And negative 7 times 2 is negative 14. Alright, so let's add all this up. X cubes, 12x cubed. The squares, negative 16 minus 21, that's negative 37x squared. X's, 8x plus 28, that's going to be 36x. Then minus the 14. So this right here, this is what my area is. So that's what goes here. Okay, so that's the area. Now again, in terms of units, because I know some teachers are picky about that. When you're doing perimeter, it is just going to be the unit itself. So again, feet, meters, inches. Okay, so you'd write 6x squared minus 10x units, or whatever it is. When you're doing area, remember it is going to be units squared, or you would have it as square, you'd do square units. Okay, so you would write your units like that. Again, some teachers are very fussy with that, so make sure you know what your teacher likes to do here. Okay, but also you should know what your units will be. Okay, all right, so that's the end of this video. Hopefully you learned a lot. It reinforced quite a few things, and again, I will see you in the next lesson.